This is Mr. Coker with Foundations of Algebra Lesson 8.4, Domain and Range. So I want to start by talking about a couple of pieces of vocabulary. First of all, what is domain and what is range? So domain is the list of all of the x values of a function. And in the examples I'm going to do, it's shown on a coordinate plane. However, you could see it in a list of points or on a table. I'm just hoping to show it on a graph. The range is a list of all the y values. So, domain, list of x values, range, list of y values. And that's what we're going to definitions we're going to go with, and that's what we're solving, we're answering. Domain is going to be what are the x values, and range are what are the y values. Okay, second piece of vocabulary to get out of the way. Discrete, continuous. So the first graph here is a discrete graph. It has discrete points, and what this means is that there are a few points on the graph, but if you look, the points are not, there's no line, they're not connected. Oftentimes, I've noticed when they ask you find domain and range, oftentimes it's this kind of graph, but it's also less practical, but it is worth going over. So, for domain, we're going to look at only the x-axis. We're going to look at what numbers are represented on this x-axis. Remember, x and y. So we want to look on the x-axis and we want to say what numbers are represented. We're going to list them. So the first point, and we want to go left to right. We're going to go smallest to biggest. So the first point we encounter is here. And if you look, this is at -1, -2. We're at -2 on the x-axis. I'm going to write down -2. Secondly, we have 1 at -1. I'm writing -1. We don't have anything at 0, we don't have anything actually until we get to +1. But at +1, you notice we have two, correct? We have two points. Now, we do not have to write that number twice, we only need to write it once. 1 is represented twice, but we only need to put it once as the domain. We have one more point, and it's this one, and it's at number 2. And it's 2 because of the x-axis. We start, this is the point of origin, 0, 0. There's 1, here's 2. That is our domain. For range, we're looking at the y values. I want to start at the bottom. At the bottom of the graph, we have this point that we mentioned before. Well, now we're going to count it. It's at -2. Here's 0, -1, -2. So we are at -2, and that's where we're starting. We then go up until we reach 1. Notice there's nothing on here between -2 and 1. So here's 1. We have 3 points at 1, but again, we only need to write the one time. And then we have the last point, which is at 2 on the y-axis. And then that is our range. Now that's a discrete graph. What if we have continuous? Discrete is easier to list the points because we can actually look, and we can look at all the points on the graph. continuous graphs, we cannot do this. I'm going to start though by writing the D for domain and R for range. Now if you look at this one is starting at 2 and negative 2 on the x-axis. So again, I need to go ahead and put my x and my y. On the x-axis, again, we're our furthest left, we're starting at negative 2, and I'm going to put negative 2. We're ending, if we go all the way to the end, the next point we have listed here is at 3. But there's an issue here. What other points do we have? It's a line. It's a line segment, and like the whole area between negative 2 and 3 is covered by this line. It's all represented. It's all part of our domain. Well, this is the format we want to write it in. So, if you remember back to the inequality lessons, or anytime you've learned about inequalities in the past, when we have a filled-in circle, that means less than or equal to or greater than or equal to. This is the format I'm going to use for this. Our lowest number, our furthest left number is negative 2. So we have negative 2 less than or equal to x. And then our biggest number is 3, and we have less than or equal to 3. That is our format. What this means is that x, the domain, is anything equal to negative 2, because obviously negative 2 is part of the domain. Anything bigger than negative 2 and anything bigger than negative 2 that is equal to 3 or less than 3. So it's either equal to or between negative 2 and 3. For range, we do the same thing, only now we use the y-axis. We look at our lowest point in the graph. Now we want to always start with the lowest. You can start with the biggest and flip the signs around, but I like to make things simpler, and part of that is to stay consistent. So I want to always start with the lowest number, which is negative 3. Then I'm going to find the highest number. That's the highest point in our graph. Well, we have 1, 2, 3. It's positive 3. Before I finish this, I want to make clear, because sometimes students get confused. When this says these two 3's are not the same 3. This is one of the 3. Is that 3 on the x-axis? That's the domain. The range refers to this 3 on the y-axis. Make that clear. Okay, we're going to do the same thing, putting less than or equal to and less than or equal to. But in between, would we put x? No, we would not put x, because this is the range, and range is the list of y values. So now we put y. Remember, domain is the list of x values. That's why we put an x. And then range is the list of y values, which is why we put a y. Last thing, just to help you kind of visually with this, one thing that I found that sometimes can help students is to visualize the range. Like domain and range. So here's the domain. The domain is stretching from negative 2 to 3. And it can help sometimes to kind of draw a visualization of it. Same thing for range. So here's our range, and it's starting at -3 and ending at +3. And it can help sometimes kind of to do that so you can visualize the, you know, if you're a visual learner, it can help a little bit. So anyway, that's domain and range, and this is from a graph. Like I said before, sometimes you're asked to find domain and range from a set of points or from a table, something like that. But that's not what I'm going into in this video. We're just talking about from a graph. By the way, it also works not just with linear equations, but with other types of equations. And later on, I will make a video talking about domain and range when you have linear, exponential, and quadratic graphs. So anyway, thanks for watching.